Thank you. That was pretty incredible, right? But that was you. That was you. Thank you. Well, Taiwan doesn't just build supercomputers for the world. Today, I'm very happy to announce that we're also building AI for Taiwan. And so today we're announcing that Foxconn, Taiwan, the Taiwanese government, Nvidia, TSMC, we're going to build the first giant AI supercomputer here for the AI infrastructure and the AI ecosystem of Taiwan. Thank you. Is there anybody who needs an AI computer? Any AI researchers in the audience? Every single student, every researcher, every scientist, every startup, every large established company, TSMC themselves does enormous amounts of AI and scientific research already. And so Foxconn does an enormous amount of work in robotics. I know that there are many other companies in the audience, I'm going to mention you in just a second, that are doing robotics research and AI research. And so having a world-class AI infrastructure here in Taiwan is really important. Those 9 switches are connected by this miracle. This is quite heavy. That's because I'm quite strong. I made it look so light, but this is 70 pounds. And so this is the NVLink spine. 2 miles of cables, 5,000 cables structured, all coaxed, impedance matched, and it connects all 72 GPUs to all of the other 72 GPUs across this network called NVLink switch. 130 terabytes per second of bandwidth across the NVLink spine. So just put in perspective, the peak traffic of the entire internet, is 900 terabits per second. Divide that by 8. This moves more traffic than the entire internet. 1 NVLink spine across this 9 of these NVLink switches, so that every single GPU can talk to every other GPU at exactly the same time. This is the miracle of GB200. And now the GPU performance is incredible, the amount of memory is incredible, the networking bandwidth is incredible, and now we can really scale these out. Once we scale it up, then we can scale it out into large systems. And notice almost everything NVIDIA builds are gigantic. And the reason for that is because we're not building data centers and servers, we're building AI factories. This is CoreWeave. This is Oracle Cloud. The power density of each rack is so great, they have to put them further apart so that the power density could be distributed. But really, in the end, we're not building data centers, we're building AI factories. And this is the XAI, Colossus factory. This is Stargate, 4 million square feet, 4 million square feet, 1 gigawatt. And so just think about this factory here. This 1 gigawatt factory is probably going to be about, 60 to 80 billion dollars. Out of that 60 to 80 billion dollars, the electronics, the computing part of it, these systems are 40, 50 billion dollars of it. And so these are gigantic factory investments. The reason why people build factories is because you know the answer. The more you buy, say it with me. The more you buy, the more you make. That's what factories do. Okay. The technology is so complicated. And in fact, just looking at it here, you still cannot get the deep appreciation of the amazing work that's being done in all of our partners and all of the companies here in the audience in Taiwan. And so we made you a movie. I made you a movie. Take a look.
Blackwell is an engineering marvel. It begins as a blank silicon wafer at TSMC. Hundreds of chip processing and ultraviolet lithography steps build up each of the 200 billion transistors, layer by layer, on a 12-inch wafer. The wafer is scribed into individual Blackwell die, tested and sorted, separating the good dies to move forward. The chip-on-wafer on substrate process, done at TSMC, SPIL, and Amkor, attaches 32 Blackwell dies and 128 HBM stacks on a custom silicon interposer wafer. Metal interconnect traces are etched directly into it, connecting Blackwell GPUs and HBM stacks into each system and package unit, locking everything into place. Then the assembly is baked, molded, and cured, creating the Blackwell B200 superchip. At KYEC, each Blackwell is stress-tested in ovens at 125 degrees Celsius and pushed to its limits for several hours. Back at Foxconn, robots work around the clock to pick and place over 10,000 components onto the Grace Blackwell PCB. Meanwhile, additional components are being prepared at factories across the globe. Custom liquid cooling copper blocks from Cooler Master, AVC, Auras, and Delta keep the chips at optimal temperatures. At another Foxconn facility, ConnectX-7 SuperNICs are built to enable scale-out communications, and Bluefield 3 DPUs to offload and accelerate networking, storage, and security tasks. All these parts converge to be carefully integrated into GB200 compute trays. NVLink is the breakthrough high-speed link that Nvidia invented to connect multiple GPUs and scale up into a massive virtual GPU. The NVLink switch tray is constructed with NVLink switch chips, providing 14.4 terabytes per second of all-to-all bandwidth. NVLink spines form a custom blind-mated backplane, integrating 5,000 copper cables to deliver 130 terabytes per second of all-to-all bandwidth. This connects all 72 Blackwells, or 144 GPU dies, into one giant GPU. From around the world, parts arrive. From Foxconn, Wistron, Quanta, Dell, Asus, Gigabyte, HPE, Supermicro, and other partners to be assembled by skilled technicians into a rack-scale AI supercomputer. In total, 1.2 million components, 2 miles of copper cable, 130 trillion transistors, weighing 1,800 kilograms. From the first transistor etched into a wafer to the last bolt fastening the Blackwell rack, every step carries the weight of our partners' dedication, precision, and craft. Blackwell is more than a technological wonder. It's a testament to the marvel of the Taiwan technology ecosystem. We couldn't be prouder of what we've achieved together. Thank you, Taiwan.
Okay, let's talk about robots. So agentic AIs, AI agents, a lot of different ways to say it, agents are essentially digital robots. Reason for that is because a robot perceives, understands, and plans. And that's essentially what agents do. But we would like to build also physical robots. And these physical robots, first, it starts with the ability to learn to be a robot. The ability to learn to be a robot can't be done in the physical world productively. You have to create a virtual world where the robot can learn how to be a good robot. that virtual world has to obey the laws of physics. Most physics engines don't have the ability to, with fidelity, deal with rigid and soft body simulation. And so we partner with DeepMind, Google DeepMind, and Disney Research to build Newton, the world's most advanced physics engine. It's going to be open sourced in July. It's incredible what it can do. It's completely GPU accelerated. It's differentiable, so you could learn from experience. It is incredibly high fidelity. It's super real time. And so we could use that Newton engine, and it's integrated into Mujoko. It's integrated into NVIDIA's Isaac Sim. So irrespective of the simulation environment and framework you use. And so with that, we can bring these robots to life. Who doesn't want that? I want that. Can you imagine one of those little ones or a few of them running around the house, chasing your dogs, driving them crazy? And so, did you see what was happening? It wasn't an animation, it was a simulation. And he was slipping and sliding in the sand, in the dirt. All of it was simulated. The software of the robot is running in the simulation. And so it wasn't animated, it was simulated. And so in the future, we'll take the AI models that we train and we put it into that robot in simulation and let it learn how to be a great robot. Well, we're working on several things to help the robotics industry. Now, you know that we've been working in autonomous systems for some time. Our self-driving car basically has 3 systems. There's the system for creating the AI model, and that's GB200, GB300. It's going to be used for that, training the AI model. Then you have Omniverse for simulating the AI model. And then when you're done with that AI model, you put that model, the AI, into the self-driving car. Okay, this year we're deploying Mercedes around the world, our self-driving car stack, end-to-end stack. But we create all of this, and the way we go to market is exactly the same that we work everywhere else. We create the entire stack, we open the entire stack, and for our partners, they use whatever they want to use. They could use our computer and not our library. They could use our computer, our library, and also our runtime. However much you would like to use, it's up to you. Because there's a lot of different engineering teams and different engineering styles and different engineering capabilities. We want to make sure that we provide our technology in a way that makes it as easy as possible for everybody to integrate NVIDIA's technology. You know, like I said, I love it if you buy everything from me, but just please buy something from me. Okay. Very practical. And so we're doing exactly the same thing in robotic systems, just like cars. And so this is our Isaac GR00T platform. The simulation is exactly the same as Omniverse. The training system is the same. When you're done with the model, you put it inside this Isaac GR00T platform. And Isaac GR00T platform starts with a brand new computer called Jetson Thor. This is just started in production. It is an incredible processor. Basically, a robotic processor goes to self-driving cars, and it goes into a humanoid robotic system. On top is an operating system we call NVIDIA Isaac. The NVIDIA Isaac operating system is the runtime. It does all of the neural network processing, the sensor processing, pipelines all of it, and deliver actuated results. And then on top of it, pre-trained models that we created with an amazing robotics team that are pre-training these models. And all the tools necessary in creating this, we make available, including the model. And so today we're announcing that Isaac GR00T N1.5 is now open sourced. And it's open to the world to use. It's been downloaded 6,000 times already. And the popularity and the likes and the appreciation from the community is incredible. And so that's creating the model. We also open the way we created the model. The biggest challenge in robotics is, the biggest challenge in AI overall is, what is your data strategy? And your data strategy has to be, that's where a great deal of research and a great deal of technology goes into. In the case of robotics, human demonstration just like we demonstrate to our children or a coach demonstrates to an athlete. You demonstrate using teleoperations. You demonstrate to the robot how to perform the task, and the robot can generalize from that demonstration, because AI can generalize and we have technology for generalization. You can generalize from that one demonstration other techniques, okay? And so what if you want to teach this robot a whole bunch of skills? How many different teleoperation people do you need? Well, it turns out to be a lot. And so what we decided to do was use AI to amplify the human demonstration systems. And so this is essentially going from real to real and using an AI to help us expand, amplify the amount of data that was collected during human demonstration to train an AI model. Let's take a look. Well, as I mentioned earlier, the world has a severe shortage of labor. And the reason why humanoid robotics is so important is because it is the only form of robot that can be deployed almost anywhere brownfield. It doesn't have to be greenfield. It could fit into the world we created. It could do the tasks that we made for ourselves. We engineered the world for ourselves, and now we could create a robot that fit into that world to help us. Now, the amazing thing about human robotics is not just the fact that if it worked, it could be quite versatile. It is likely the only robot that is likely to work. And the reason for that is because technology needs scale. Most of the robotic systems we've had so far are too low volume. And those low volume systems will never achieve the technology scale to get the flywheel going far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But humanoid robot, it is likely to be the next multi-trillion-dollar industry. And the technology innovation is incredibly fast. And the consumption of computing and data centers, enormous. But this is one of those applications that needs 3 computers. One computer is an AI for learning. One computer is a simulation engine where the AI can learn how to be a robot in a virtual environment, and then also the deployment of it. Everything that moves will be robotic. As we put these robots into the factories, remember, the factories are also robotic. Today's factories are so incredibly complex. This is Delta's manufacturing line, and they're getting it ready for a robotic future. It is already robotics and software defined, and now in the future, there'll be robots working in it. In order for us to create robots and design robots that operate as a fleet, as a team, working together in a factory that is also robotic, we have to give it omniverse to learn how to work together. And that digital twin, you now have a digital twin of the robot, you have a digital twin of all of the equipment, you're gonna have digital twin of the factory. Those nested digital twins are gonna be part of what Omniverse is able to do. This is Delta's digital twin. This is WeWin's digital twin. Now, while you're looking at this, if you look at it too closely, you think that it's in fact photographs. These are all digital twins. They're all simulations. They just look beautiful. The image just looks beautiful, but they're all digital twins. This is Pegatron's digital twin. This is Foxconn's digital twin. This is Gigabyte's digital twin. This is Quanta's. This is Wistron's. TSMC is building a digital twin of their next fab. As we speak, there are $5 trillion of plants being planned around the world. Over the next 3 years, $5 trillion of new plants. Because the world is reshaping, because reindustrialization moving around the world, new plants are being built everywhere. This is an enormous opportunity for us to make sure that they build it well and cost effectively and on time. And so putting everything into a digital twin is really a great first step and preparing it for a robotic future. In fact, building that $5 trillion doesn't include a new type of factory that we're building. And even our own factories, we put in a digital twin. This is the Nvidia AI factory in a digital twin. Kaohsiung is a digital twin. They made Kaohsiung a digital twin. There are already hundreds of thousands of buildings, millions of miles of roads. And so, yes, Kaohsiung is a digital twin. Let's take a look at all of this.
Taiwan is pioneering software-defined manufacturing. TSMC, Foxconn, Wistron, Pegatron, Delta Electronics, Quanta, WeWin, and Gigabyte are developing digital twins on Nvidia Omniverse for every step of the manufacturing process. TSMC with MedAI generate 3D layouts of an entire fab from 2D CAD and develop AI tools on CUOPT that can simulate and optimize intricate piping systems across multiple floors, saving months of time. Quanta, Wistron, and Pegatron plan new facilities and production lines virtually prior to physical construction, saving millions in costs by reducing downtime. Pegatron simulates solder paste dispensing, reducing production defects. Quanta uses Siemens Teamcenter X with Omniverse to analyze and plan multi-step processes. Foxconn, Wistron, and Quanta simulate power and cooling efficiency of test data centers with Cadence Reality Digital Twin. And to develop physical AI-enabled robots, each company uses its digital twin as a robot gym to develop, train, test, and simulate robots. Whether manipulators, AMRs, humanoids, or vision AI agents as they perform their tasks, or work together as a diverse fleet. And when connected to the physical twin with IoT, each digital twin becomes a real-time interactive dashboard. Pegatron uses Nvidia Metropolis to build AI agents who help employees learn complex techniques. Taiwan is even bringing digital twins to its cities. LinkerVision and the city of Kaohsiung use a digital twin to simulate the effects of unpredictable scenarios and build agents that monitor city camera streams, delivering instant alerts to first responders. The age of industrial AI is here, pioneered by the technology leaders of Taiwan, powered by Omniverse.
My entire keynote is your work. It's so excellent. Well, it stands to reason that Taiwan, at the center of the most advanced industry, the epicenter where AI and robotics is going to come from, it stands to reason that this is an extraordinary opportunity for Taiwan. This is also the largest electronics manufacturing region in the world. And so it stands to reason that AI and robotics will transform everything that we do. And so it's really quite extraordinary that for one of the first times in history, that the work you do has revolutionized every industry, and now it's going to come back to revolutionize yours. I have a new product. I announced several products already today, but I have a new product to announce. We've been building out in Space Dock for some time. And I think it's time for us to reveal one of the largest products that we've ever built. And it's parked outside, waiting for us. Let's see how it goes. Nvidia Constellation. Nvidia Constellation. Well, as you know, we have been growing. And all of our partnerships with you have been growing. The number of engineers we have here in Taiwan have been growing. And so we are growing beyond the limits of our current office. And so I'm going to build them a brand new Nvidia Taiwan office, and it's called Nvidia Constellation. We've also been selecting the sites. We've been selecting the sites, and all of the mayors and all the different cities have been very kind to us. And I think we got some nice deals. I'm not sure. It seems quite expensive. But prime real estate is prime real estate. And so today, I'm very pleased to announce that Nvidia Constellation will be at Beitou Xiling. We have negotiated the transfer of the lease from the current owners of that lease. However, I understand that in order for the mayor to approve that lease, he wanted to know whether the people of Taipei approve of us building a large, beautiful Nvidia Constellation here. Do you? He also asked for you to call him. And so I'm sure you know his numbers. Everybody call him right away. Tell him that you think it's a great idea. So this is going to be Nvidia Constellation. We're going to build it. We're going to start building as soon as we can. We need the office space. Nvidia Constellation, Beitou Xiling. Very exciting. Okay. Well, I want to thank all of you. I want to thank all of you for your partnership over the years. We are at a once-in-a-lifetime opportunity. It is not an understatement to say that the opportunity ahead of us is extraordinary. For the very first time in all of our time together, not only are we creating the next generation of IT, we've done that several times. From PC to internet to cloud to mobile cloud, we've done that several times. But this time, not only are we creating the next generation of IT, we are in fact creating a whole new industry. This whole new industry is going to expose us to giant opportunities ahead. I look forward to partnering with all of you on building AI factories, agents for enterprises, robots, all of you amazing partners building the ecosystem with us around one architecture. And so I want to thank all of you for coming today. Have a great Computex, everybody. 大家谢谢. Thank you. Thank you for coming. Thank you.